Hi everyone, welcome to this week's Spatial Spotlight. My name is Helen and I'm going to be talking today about spatial interpolation. So I've got a few slides to show you and then we are going to head straight on to a live demo of different interpolation techniques. So let me just share my screen. Hopefully you can see that. Interpolation, what is it? So interpolation is all about finding and estimating missing values in your data. So that could be because your data has errors in it. It could be because there's been uneven sampling in your dataset collection. It could be that there are just gaps in the data. Or it could be that you are wanting to create a more sort of detailed or smooth visualization, but it's just really coarse and you just want to smooth it out a little bit. So in all those cases, you need interpolation. So today I'm going to be talking about two main techniques for running interpolation. So there are a bunch of different techniques out there. These are the two that you'll probably hear the most about. So first of all, we have inverse distance weighted interpolation. You'll often hear this referred to as IDW. So this is where unknown locations have their values calculated by assigning weights to the known values around it and using those weights to calculate that missing data point. So generally, the closer a point is to the unknown or missing value, the higher the weight is in determining that new value. So this is a fairly simple technique. It's quite easy to explain, it's quite easy to do, and that also means it's pretty fast to run as well. The limitations here are it's really sensitive to outliers. So if one of those known values is really anomalous, so it could be that it's an error or it could just be that it's really, really different, then that will have a huge impact on calculating that missing value in a way that it perhaps shouldn't. And also this doesn't account for spatial correlation, so this technique doesn't account for any trends within your spatial data. The second technique we're going to talk about today is Kriging. So this is a slightly more complicated technique. It takes into account both the distance of known values to your unknown values, but also the spatial correlation, autocorrelation, of those data points. So it can work out where there are local variations and local trends and incorporate that into the calculation of the unknown value. So a really great advantage for this technique is it provides estimates of uncertainty. So it tells you how confident you can be that the value that it's calculated is correct. And another great advantage, again, is that it takes into account local levels of spatial autocorrelation, so those local trends in your data. A few limitations, though, is this might sound like a much better technique than IDW because it takes into account that spatial autocorrelation, but because of that, it's much more computationally demanding, and it also requires a lot more prior knowledge from the person doing the analysis. So it's really not for beginners. You need to have that sort of statistical knowledge to be able to do it. You need to be able to appropriately select a variogram model. You need to understand concepts like stationarity and isotropy. So there's a lot more prior knowledge that you, as the analyst, need to be able to run this technique. So when you're considering which technique to use, there's a few things you should consider. So first of all, the characteristics of the data. So are you expecting levels of spatial autocorrelation or not? Is that something you want to take into account in your calculation? Also, what's the sort of size of the data? What scale are you running the analysis at? Which that might determine, do you want to use a more simple technique because you need to get it to run faster? And then finally, you need to think about you as the analyst. So what is your experience? Are you confident that you can run a Kriging interpolation with appropriately and know all of the prerequisites that it needs to be able to run and give you the best results? And then I would say often most importantly is what is your objectives? What are you trying to learn from the analysis? How quickly do you need to do it? And do you need to know things like uncertainty? Do you need to know how confident you are in the results? So those are things you need to consider. And here is how that might materialize when you're making a decision. So you might want to use IDW if you need to do something fast and simple and efficient. It's really great if you want to do something that has a smoothing technique. So I mentioned at the start that sometimes interpolations are used to create much more aesthetically pleasing visualizations. So IDW is great for creating those really smooth visualizations. And finally, if you're expecting similar values to be located close together, then IDW is perfect for that. So an ideal use case for this might be terrain elevation. So with terrain modeling, you'd expect similar values to be located close together. Unless you're mapping something like a gorge or a really mountainous area, you'd be expecting really like low values to be located close together, high values to be located close together, so it's ideal for that. Kriging is more appropriate if you have more complex spatial patterns in your data, and maybe you require estimates of uncertainty, so you want to know how confident you can be in the results of your analysis. So a more ideal use case here might be something like traffic density modeling, where you might expect much greater local variation in your data. So you might get like a really busy main road located really close to a really quiet local road. So that's a more ideal use case for that. So let's take a look at the two of them in action. So let me just come out of my slides. Hopefully you can still see everything fine. So what we are going to do today is we're going to look at elevation for Arizona in the US, and we are going to remove some of the values, the elevation values, and then we're going to use both techniques to calculate those missing values and then compare them to the real results to see how, or compare them to each other and compare them to the real results to see how good the techniques were in this case. So the data set we're going to use for this is Carto's spatial features. So first of all, if you don't have a Carto account, it's no problem. You can head to carto.com and sign up for a free 14-day trial, and you'll have access to absolutely everything that I'm showing you today. One of the things you get access to is our spatial data catalog, which has about 12,000 data sets that you can subscribe to on the cloud, so you don't need to download anything. It's all there in the cloud, so you can really easily access it. One of those data sets is spatial features, which is a global grid system, which includes data on things like demographics, elevation, environment, climate, all those things. We can take a little look here. So we are interested just in elevation, which you can see here. We've got elevation based on ASTA Global Digital Elevation Model. That's a mouthful. So this dataset is based on H3, which is a global hexagonal grid. It's something called a spatial index, which I won't go into in too much detail because loads of our other webinars go into it in a lot of detail. It's a really fascinating topic. But basically the gist of spatial indexes is they're geolocated using this short geo ID here. So Carto knows where to place each hexagonal cell on the world and how big it needs to be by this short little string here, rather than using a really long geometry column like a lot of datasets do, which is obviously really heavy and slow to analyze. So these enable really fast analysis. So that's the basis of our analysis. I'm just going to head into Carto Builder, which is our mapping and analytics tool, just to talk through what we're going to be doing. So this is Arizona. We can see this green data set. Actually, the base map isn't really showing this off here. Let's just change the base map so it's a bit easier to see. This sort of green grid that we have here is elevation in Arizona. So you can see we've got the beautiful Grand Canyon up here to the north, and then we've got slightly more gentle terrain sort of ruggedness down here to the south. So what we're going to be doing is removing some of these values and then interpolating them and seeing how accurate they were. So what I've just done is I've seen all of these, if you look at all these little pink hexagons here, these are the areas that I've removed basically. I've randomly selected 20% of all of the hexagonal cells in Arizona, and we're going to try and calculate their elevation using interpolation. So the way that we're going to do that is if we just head over into Carto documentation, this is where you can find everything that you need to know about Carto, about developing apps, about creating amazing maps, and about running analysis. What we are doing today is interpolation. So I'm just going to head down to our analytics toolbox. Now, if you're not familiar with Carto, what makes us really different and really special and really awesome, I think, is that we connect natively to cloud data warehouses like Google BigQuery and Snowflake and Redshift and Databricks. So you keep all of your data and all of your analysis happens in there. We plug into that and run the analysis in there for you. So that makes things really, really fast. It means you don't have to be always moving your data in and out and putting it back in. So that's how Carto sort of works. So you can see we've got analytics toolbox here for each of our cloud data warehouses that we connect to. I'm working in Google BigQuery today, so I'm just heading into SQL reference and down to statistics, which is where we keep all of our spatial data science tools and components. Now, if you don't code, this is all based on SQL, but if you don't code, we do have a low-code interface called Kato Workflows where you can do a lot of what I'm showing you and a lot of analysis in there. But for this specific tool, it is SQL-based, but I'm going to show you in a second. It's really straightforward, even if you don't think you're a SQLer. So I'm just going to scroll down here and you can see we've got our interpolation tools in here. So let's look at IDW first. Now, I'm not going to run this code today because all you'd be doing is watching me make loads and loads of typos and watch us slowly create some code and then run it. So I've already pre-run this, but I'm just going to talk through how you sort of structure this code. So in the documentation, you head to whichever tool you want to run and you can see you get loads of information about what you need to run that tool. And you also get this example SQL code here, so you can structure your code around that. So you can see for IDW, you only really need a couple of things. So you need your input sample. So this is, for us, that is all of these non-pink areas. So this is our input sample. This is the data we're going to use for interpolation. Then we need our origin. So these are the areas that are going to be interpolated. So these are these pink cells here. And then finally, we just need to set our sort of neighborhood statistics. So that is, what is the maximum distance that we want to take points into account to run this analysis? What's the maximum number of neighbors? What's the power of distance? So you can see for IDW, it's quite straightforward to run. You only really need to know a few things. If I head over to Kriging, on the other hand, you still need to know a lot of those things as well. So again, we have sample points, we have interpolation points, max distance, etc. But you can see we also need to include the parameters for our variogram, and we also need to include our semi-variance model parameters as well. So when I was talking earlier about you needing to have that slightly more advanced knowledge to be able to run Kriging effectively, this is what I mean. You need to have knowledge on those things. So, like I mentioned, I have pre-run these, but what you would need to do if not is just copy this code into your BigQuery console or whichever Cloud Data Warehouse console you are using, and just add in your own parameters and run that. And depending on the sort of scale of your data, it shouldn't take too long at all. So let's take a look at the results of this analysis and compare the two. So what we have here is histograms showing the error in the analysis that we've just run. So at the top we have IDW and at the bottom we have Kriging. We can see that they look pretty good. We've got a lot of error clustered around 0 and the really small levels. Both of them are kind of under predicting a little bit, but in general the error's pretty good. It's quite difficult to tell the two just from the histograms because they look so similar. So we should defer to the RMSE. So we can see here that Kriging has a slightly lower RMSE than IDW. So in that case, we can say that we think that Kriging is a more accurate method for running interpolation for this use case. However, that's not the whole story, and I just want to really quickly, before the end of this, take a look at how error is distributed geographically. So I'm just going to head on over to this map. Oh, that's actually very difficult to see the results on that base map, so I'll just swap to a dark base map. So the white areas here are where the error is really, really low. It's negligible. We're not so worried about it. On where we have purple areas of error, that's where the interpolation has under-predicted the elevation, and green areas are where it's over-predicted. So on the left here, we have the results of IDW interpolation, and on the right here, we have Kriging. So you can actually see, let me just close these legends now, so you can see a bit more clearly. So you can actually see that generally, particularly in the south and east of Arizona, there's not very much error at all. But as we zoom in to the northwest, we can see that most of the error is actually clustered in this area. And if you are familiar with Arizona, you can probably guess why that is. And I'll just switch to an aerial base map to help tell the story. The reason the error is really clustered in this geographic region is because this is where the Grand Canyon is. So this is where, we're all familiar with what it looks like. It's this really dramatic gorge. The elevation is really, really rugged and changes really quickly. So in that sense, it's a really tough job for interpolation to accurately predict elevation in these areas, particularly IDW. So if you remember at the start of this analysis, I was saying that IDW is a really great method for predicting terrain and elevation because those changes are typically so gradual. But you can see here that actually because the changes aren't that gradual and we have that level of spatial autocorrelation and those local patterns, that's probably why Kriging has actually generally performed better in this case. Another reason why we've got a lot of error in this area is because you can see these hexagons are actually pretty large scale. So I think they're about 300 meters across. And you can see that the elevation actually changes much more dramatically than that. We'd need a much finer resolution in our analysis, in our source data, to be able to accurately predict the resolution, the elevation, So I think those are the sort of two main takeaways that I would take from this example. Is A, like with all spatial analysis, there's often like a rule and best practice, but you really need to think about whether that definitely applies for your use case. It didn't here. And then secondly, make sure that the level of spatial detail you have in your source data is appropriate for the data that you are trying to predict. So I think that is pretty much everything from me. Thank you so much for coming along to this little webinar. We do these every week, so please do come back, same place, same time, to hear from one of my colleagues. And thank you again for coming, and have a great rest of your day. Bye.